by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
Welcome to the show, ladies and gentlemen. Another episode of Cosmic Catastrophe on Revolution Radio, Studio B, 12 noon, every Saturday, Mountain Time. My lovely co-host, Leah Shaper, is joining us today.
She's up.
I was going to say up in the box there, but it's not how it looks on the screen.
Oh, I see.
It's just how I'm looking at it. All right, we're going to have a great show today. The title of the show is Cosmic Dust and Cosmic Rays. What do we really know? And we're going to dive into the topic. This is interesting because I've never really done a deep dive into the dust, any deep dive into the rays. I've mostly looked at the most recent work with Svensmark and the cloud experiment as far as cosmic rays are concerned, because it's important when you're doing work like I'm doing on the channel where I'm trying to do long-term forecasting of climate. It turns out that clouds are pretty important to climate. So
yeah, what do you know? And then depending on who you ask, you know, which direction they influence climate on, but I'm sure you'll get to that.
Yeah, we'll get to that by the end of the show. But before we get started, I want to talk a little bit about the fact that we've only recently discovered cosmic dust and cosmic rays very recently. They first discovered something radioactive going on as early as 1899 with these balloon experiments. I don't remember the guy's name. We'll get to it.
Well, I can tell you that. Victor Hess in 1912.
Yeah,
1912.
Well, the 1912 and 13 experiments were when he got high enough to actually discover that the radiation wasn't diminishing.
Well, and that it increases as you go higher up in altitude.
Yeah,
that was a pretty important part.
Up to that point, all the scientists on Earth that found radiation on Earth, like we do have uranium and other things, but there's also this radioactive background that you could pick up everywhere. You know, like granite has a certain amount of radioactivity and so on. They thought all the radioactivity that we were monitoring was coming from rocks and the dirt.
Exactly.
And how wrong were they? Let's share the screen here. Unfortunately, the radio people won't be able to see that, but our show is on at night, is it not?
It is. It is on Saturday evenings, usually somewhere between 7 and 8 o'clock Mountain Time on Magnetic Reversal News. So if you missed the live broadcast or you want to see the video, you can catch us tonight.
Beautiful. And can you see the screen?
Yes.
All right. So we're sharing the screen, and it's the background on cosmic dust. And it's a pretty good background. And I want to get into some interesting numbers here in the first half of the show on how much of this stuff is actually raining down upon us. Now, a lot of people refer to cosmic dust as space dust, and they don't know what they're talking about when they're using that term, but it's actually cosmic dust. It can also be referred to as extraterrestrial dust, and obviously the most well-known stardust.
We are all made of stardust, are we not?
Yeah, and in fact, we are all made of stardust, and that will be part of the conclusion here. So this dust, it occurs in outer space, and it's falling down on Earth, and we've only recently got some really good numbers in it. Most of the dust particles are between 0.1 millimeter and 100 microns, which I thought is the same size. But once you get above that, then they start calling them micrometeoroids, because it's actually like a sand grain size and it could hurt you. And then obviously the largest particles are called meteoroids. Anything to interject here?
Nope.
Yeah, and then they break it down into three types: interstellar dust, intergalactic dust, and interplanetary dust. And they're different types of dust because when you have these planetary systems like a solar system, you've got a lot of asteroids and things that hit planets, and they're blowing up planetary material into space. So that would be the interplanetary dust, which would be mostly from impacts and objects hitting. And so the interstellar dust and intergalactic dust is thought of as being part of stars exploding, like supernova. But regardless of where this dust comes from, it turns out that it's radioactive. And that's kind of interesting.
You know, it might be important too to make that distinction between, let's say, interplanetary and intergalactic, right? Because the chemical signatures of the dust surely help us determine where it came from, right? You know, one planet has a different composition than another, one star has a different composition than another.
Yeah, and it's and we really don't know anything about it. Even up to this point, they have hypotheses, but they don't know where galactic cosmic rays are coming from, and they really don't know where the dust is coming from, except to say space.
Yeah, put a pin in that, not really knowing where cosmic rays come from, because I've got some interesting notes about that.
Cool. We'll probably focus on the cosmic ray part in the second half.
Yeah.
Now, Don Brownlee at the University of Washington in Seattle was the first to reliably identify the extraterrestrial nature of dust that he was collecting. And this was in the late 70s. So we've only known that dust is raining down on us for like 50 years. That's insane. So if you think that science has it all figured out, we're newbies to this game.
Oh my gosh, yes.
Yeah. Now, when you start to look at it in layman's terms, the numbers are insane. 5,000 tons of extraterrestrial dust are falling on Earth every year.
That's so hard to comprehend.
Yeah.
It's really hard to get your head around that.
Because a ton is 2,000 pounds, and there are 5,000 2,000-pound units of dust falling on Earth annually.
Right.
That's, if you can do the math, it's 10 million pounds a year of cosmic dust. So if we multiply that out to just a million years, geologic history, we'll do 1 million years. That turns into 10 trillion pounds every million. Now multiply that by like 500 million. 10 trillion times 500 million is an unimaginably large number. It's in the quintillions. Now, this is kind of not significant. If you didn't know, this number on the screen is the weight of the Earth. And you can say it two ways. The weight of the Earth is 13,170 billion trillion pounds. Or the actual way you say it mathematically, because if you remember, you count up thousands, millions, billions, trillions. What comes next? Quadrillion, quintillion, septillion, sextillion, and octillion. The Earth weighs 13 octillion and 170 septillion pounds.
Isn't it much easier to use exponential figures for this?
Yeah, but the layman can't identify.
I know.
The minus 13th. They don't know what that is.
Well, even the scientists can't relate to that very well, frankly, to be honest.
So it's a big number. The weight of the Earth is big, but so is 500 million years of dust would be like 1% of the weight of the Earth. And that is significant because the crust of the Earth is about 1% of the Earth. That's amazing.
Yeah. So we can gain a whole new crust in a million years is basically what you're saying.
Well, 500 million.
Oh, sorry, I got the number wrong there. Oh, clearly I wasn't listening very well.
Yeah, the whole reason we want to put this out there is because of we're going to get into it probably in the next podcast, the expanding Earth theory. Mm-hmm. And and that began at the same time in 1899 when they were finding cosmic rays and cosmic dusts. And it was poo-pooed and it's been shut down and no one wants to revisit it. But it's now being revisited mathematically by scientists like ourselves. And even Mario Buildreps is getting into it. He found a guy to do some computer modeling. And so we'll get into that in the next show because we think the Earth was smaller and it's been accumulating mass. And we now know it accumulates 10 trillion pounds of mass every million years from dust.
You know, I just want to throw out there, I did a little bit of just a smidge of research last night just about this concept. And you know, what I find is that a lot of people will say things like, well, you know, we can't be gaining mass because at the same time we're losing mass through the atmosphere, and just like throwing out these random numbers about how much we're losing and how much we're gaining when it's like, we don't really know those figures very well.
No, and the reason why they don't accept the expanding Earth theory is because it's plate tectonics is proven.
Right.
That's laughable. We do not know the rate of subduction. We do know the rate of the mid-ocean ridge spreading, the relative age, because we can measure those stripes. But the oldest ocean floor is only 200 million years old.
Yeah.
So it throws into some weird numbers. Was the whole Earth tiny 200 million years ago and all the plates connected? And does that explain, in my geologic research, why all the continents had oceans on them?
Mm-hmm. Mm-hmm.
Because we were all underwater and only mountains were sticking up at that time.
Mm-hmm.
Yeah, it's just a fascinating subject.
Well,
and it shows you that we don't know anything, really. We're just infants.
Yes, and then it's hilarious how people will like rationalize trying to conceptualize a new potential theory. They're like, no, that's not possible. We must be losing mass at the same rate. But we don't know that at all. It's like,
and
what?
the 5,000 tons a year, that's our measurement now. When the Earth is quiet, where no mountains are being built that we can feel or see, right? There's no objects exploding in the sky nearby.
Mm-hmm.
In the past, we've had big comets come by. How much, if we go through the tail, how much more dust falls? Is it 50,000 tons?
Right. Or what happens when we go through one of the arms of the Milky Way, right? Does it increase dramatically then?
Right, because you're going to get more of the interstellar dust there.
Right.
And we happen to be in a bubble right now where it's very dust free.
Mm-hmm.
So I think those numbers can drastically change. And we certainly have, I think, proven to anyone listening that the Earth is accumulating massive amounts of material just from dust.
Oh, well, how about like one of the best examples we actually know about, which is 536 AD, right? We had a dust veil covering the entire planet. Clearly, there was a lot more dust falling to Earth at that time than there is now.
Yeah, well, that happened. That came from in the Earth from a volcano exploding, not from space. So that wouldn't be additional
as
dust.
we postulated, it probably also comes from a cometary fragment, in
Right.
fact.
So if there was a comet, it would probably be increased dust. Yeah.
And
absolutely.
increased dust from Halley's Comet, right? There's evidence of that in the GISP too.
Yeah, exactly.
Yeah.
Exactly. So, and we can see increased dust spikes in the ice core. I didn't bring that up. I wish I did.
Mm-hmm.
So we know we have lots of dust. Now, this is interesting because all of this cosmic dust is being recycled on Earth through the activity of weathering, erosion, redeposition, lithification, reweathering. Sometimes it gets completely melted, right, in subduction zones through a period of time. It's the rock cycle. So our planet is made up mostly of space dust.
Mm-hmm.
Which would then in turn mean that most biological entities, which are living on the surface, are made of the same space dust.
Mm-hmm. We are all made of stardust.
Yeah, and studies have shown that this dust contains pieces of organic molecules. So it's absolutely plausible that all biology is simply from the accumulation of space dust and a lot of time and maybe a few lightning strikes, and then you get a plant.
Yeah.
I mean, basically, that's how you do it.
And of course,
go ahead.
I was just going to say it adds a whole new dimension to like the spiritual concept of like, we are all one, right? Like literally we are. Like on a very physical level, we absolutely are. We all come from the same stuff.
Yeah, and reincarnation is real if you just call it recycling.
Yeah.
So a lot of this dust they think is from supernovas, and guess what else they think is from supernovas?
Cosmic rays.
And that brings us to Victor Hess and the discovery of cosmic rays. And in 1911 and 12, this is a nice synopsis here. I'll just read it. In 1911 and 12, Austrian physicist Victor Hess made a series of ascents in a balloon to take measurements of radiation in the atmosphere. He was looking for a source of ionizing radiation that registered on his electroscope. The prevailing theory was that radiation came from rocks in the Earth. Now, to test the theory, in 1909, German scientist Theodor Wolff measured the rate of ionizing near the top of the Eiffel Tower. That's at a height of about 900 feet, 300 meters. And he was using a portable electroscope. Though he expected the ionization rate to decrease because he's going away from the rocks in Earth, it was much less significant than it was anticipated. And then when Victor Hess took his balloons up in 1911, he discovered that it is increasing as you go higher. And that was the big breakthrough.
Yeah.
And he did this during a solar eclipse.
I was going to mention that.
To prove that the radiation wasn't coming from the sun.
Yep.
That's what makes it even more fascinating.
Yeah, and just one little figure on that. So like the ionization rate at 5,300 meters above ground level is about 4 times what you find at the surface.
And that was the highest he went in his balloon studies, and that was when it was the eclipse day.
Yeah, yeah.
So that's fascinating. All right, now can you, what happened then?
Well, I mean, later he won the Nobel Prize for this in 1936. I don't know much else about what he did after that, but there's another person named Eric Wegener who measured cosmic ray ionization as well at altitude as well as in depth, like in the ocean. So that was like in the 20s and 30s. So we're just kind of getting a little bit more refined in that period. And then in 1947, Frank Oppenheimer, brother of Robert Oppenheimer, who we should talk about Frank a little bit because his journey is a little bit related to our own.
Yeah.
But Frank Oppenheimer, he ended up at the University of Minnesota, and there was a team that was there that was already building cloud chambers that would be carried up by helium balloons. Funny little piece of trivia here. The helium balloons were sort of newly developed by the General Mills Corporation, so they were taking advantage of that. And actually, I have a picture here. This is kind of cool of Frank Oppenheimer working on one of these cloud chambers. So I don't know if you can see that oh, well, I'm too small, so you probably can't see that right now.
No, that was good. Just get it closer.
Oh, yeah? Okay.
Yeah.
So Frank Oppenheimer is the one.
Move it up a little. Yeah, that's a good shot.
Frank is the one smoking the cigarette who's sort of bending over there. So he's working on building this cloud chamber right here. That's pretty cool.
It's nice that they're keeping it really clean and stuff with the ash right above it.
Yeah, right?
That's how doctors used to smoke during surgery.
I know. It's hilarious. Oh, and by the way, that picture is from this awesome book that we have. This is called Something Wonderful, Incredibly Wonderful Happens. And this is a biography of Frank Oppenheimer. It's written by Casey Cole, who's like a science writer. It's a great book.
And we often sell it at our events. I usually get a bunch of copies and we sell it at cost. It's like $5 for the hardback.
Yeah, yeah. So okay, so he's building the cloud chambers. We've got the helium balloons, and then like at the last minute, he decides to add a stack of photographic plates, and that's the key. Because when the photographic plates come back, what was believed at that time is that cosmic rays were primarily just protons. But they come back, and Frank Oppenheimer finds one particle track that is clearly way too heavy to be a proton. And it basically proves that cosmic rays are made up of the nuclei, just the ionized nuclei. So take an atom, strip it of its electrons, and that nuclei, which has a positive charge, is a cosmic ray, basically. And he also discovers that you can get, so cosmic rays they're repelled by a magnetic field, but at the poles, all of the elements can come through in terms of cosmic rays. At the equator, there's a limit to how many are going to come through. So that's kind of interesting. And it turns out that like 99% of cosmic rays are the bare nuclei of elements, of atoms. And another 1% are solitary electrons. And then out of the 99% that are bare nuclei, you get 90% of those are just simple protons. So it's basically just the nuclei of a hydrogen atom, right? Like that's what a hydrogen atom is. It's a 1 neutron and 1 proton. Another 9% are alpha particles, which are basically helium nuclei, so also very light atoms. And then the other 1% are the nuclei of heavier elements. And those are usually called HZE ions. But you can get nuclei that are really heavy. Like you can get carbon, iron, lead, and even uranium, which is pretty interesting. And granted, it's a very small percentage of what's coming in, but the radioactive, I guess, strength of those is pretty significant, like especially for astronauts in space and such. So that was a big discovery and very important to Frank Oppenheimer is really the person that explained to us what cosmic rays are.
Yeah, interesting. And we still don't know much about them. Here's the interesting thing. They're going through all of us that are listening and participating right now. They're going through your body.
To a degree, yeah.
It's amazing. And we don't bleed and we're not dying. They're going right through the earth.
Well, like if a heavy element nuclei went through you, it would cause serious damage, right? You can literally break a DNA strand with that.
Yeah, but a single DNA strand broken may cause a single mutation, but you wouldn't be like, ow.
But you might end up with cancer.
Yeah, absolutely.
And there's more to talk about this too, about how cosmic rays kind of cascade through a series of reactions and then also come to Earth. But we can get to that in the second half.
Yeah. Let's talk more generally now. So what scientists, after the discovery of cosmic rays, some scientists wanted to know what they do. What is their effect on Earth? And then that led to like the neutrino problem. Are you familiar with that?
Yeah.
We won't get into that, but they're trying to determine where these came from. So when you start to theorize, you can get, because these particles, these stripped atoms, the nuclei are traveling insanely fast.
Oh, yeah. They're traveling way faster than anything we've ever been able to achieve in a particle accelerator.
And they don't slow down. Like there is friction in space. There's stuff out there. And these could be coming from thousands of light years away, some of them.
Right. Well, and what's sort of really interesting too. Okay, so we talked about cosmic rays coming from supernova, right? That's kind of really like the only decent hypothesis we have, but it's still not good enough, right? The idea is that you've got these ions that are coming out of a supernova, and then they get bounced around by the various magnetic fields that are in space, with other stars and planets and such. They get bounced around, and that helps them accelerate even further. But even with the super, super high energy cosmic rays that come, they're still way too fast to be explained by a supernova.
Yeah.
And we don't know how they get to be that energetic. We just don't know.
And so these are the GCRs. We also have
galactic cosmic rays, yes.
Yeah, we also have solar cosmic rays.
Right. Which are much less energetic than galactic cosmic rays are.
And so it's interesting. So suns produce cosmic rays, but they're less energetic. And then we've got these cosmic rays that are coming from outside of the solar system that are traveling at unexplainable speeds. Right there alone says a lot about the standard model of cosmology that thinks that space is a vacuum and everything is gravitational. It means it's wrong. That alone.
Yeah. Yeah.
And no one calls them out on that.
Right. Yeah. I mean, it's extraordinary, like really how little we know. I mean, I always remember when I was younger, learning about these various theories about the cosmos and astrophysics and blah, 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 blah. And like, I don't know, a lot of it just like never really seemed to fit right. Like I would listen and I would take it in and I would go, like something just doesn't feel right,
Something doesn't feel right. Like global warming doesn't feel right. Because now we know that cosmic rays may have effects on the cloud formation. Svensmark posited this back in like 2010, and the scientific community attacked him because it went against global warming, which was a really hot button issue. His paper said that the magnetic field controls galactic cosmic rays because we do have a small fluctuation on the 11-year scale Cosmic rays fluctuate about 15%. That's about it. So it's not much of a fluctuation, but it's there. But what he's posited was that it's the galactic cosmic rays are nucleating clouds and in a very particular area in the atmosphere that controls weather and temperature.
Yeah.
Oh, and there's the break. And we'll be back to put it all together.
Listen to Revolution Radio at freedomslips.com, and we'll be right back after this message.
Who owns you? If you're not in control, then someone else is. Join me, Ivy West, for Voices on the Wind, Saturday. I discuss government, health, metaphysics, suppressed science, universal mysteries, little-known incredible facts, alternative energies, and even more than you can imagine.
There was blood on the wire.
Won't you join us on Revolution Radio Saturdays for Voices on the Wind with me, Ivy West.
There are lives in the balance, people under fire, children at the cannons.
Because if your head's in the sand, your tail is a target.
Thank you for listening to Revolution Radio at freedomslips.com, the #1 listener-supported radio station on the internet. Please help support this station so this battle can continue forward. Revolution Radio!
There have been imaginative science fiction writers for generations.
Be evasive.
But that doesn't mean that they're telling the truth as opposed to fiction.
I'm aware of some archaeologists that had uncovered large bones indicating giants in Virginia. Genesis chapter 6, verse 4, there were giants in the earth in those days, and also after that, when the sons of God came unto the daughters of men, indicating that there were giants before the Nephilim.
And sons of God, plural. They weren't talking about Jesus coming down and
No, that's right. Yeah. Uh-huh.
I'm Steve Crawford. Join me every Thursday night in Studio A at 6 p.m. Eastern for Factor Theory Live. Find us on www.revolution.radio. Great guests and great stories. What do you believe?
Join me on the Brian Rouge Show on Revolution Radio, Eastern Standard Time, every Tuesday night from 6 to 8. We talk about the four most vital things, in my view, affecting all of humanity. Number one is UFOs and aliens and their agenda for the advancement of humanity. Number two is the Jewish establishment's control over all aspects of human civilization. Number three, the truth about Adolf Hitler, how he was the opposite of what we've been told. Number four is advanced ancient global civilizations. Join me on the Brian Rouge Show, Tuesday nights from 6 to 8 on Studio B on Revolution Radio.
Thank you for listening to Revolution Radio at freedomslips.com. Any commercial advertising you may hear in this program is of the sole discretion and benefit of the host of whose program you are listening to. Revolution Radio does not endorse any commercial products, nor does it accept monetary compensation for on-air advertising of commercial products, nor will it ever. We are and shall remain 100% listener supported. Any product advertising on this program are considered used at higher risk, and Revolution Radio shall not be held liable for any claims or damages received from any product advertised within this program. Revolution Radio, where information never sleeps. The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
And we're back with the second half of Cosmic Catastrophe. We're discussing cosmic dust and cosmic rays. And I always wanted to do this with the big eyeball. There it is. All right.
You need to clean your magnifying glass a little.
I just had to clean it off a little. Yeah. It's actually an antique. All right. So we discussed about who discovered cosmic dust and cosmic rays and how they did it. It's all pretty recent. We still don't know what's going on. These particles are traveling like the speed of light for light years and not slowing down and going through planets. And it's the only thing on Earth that we know of for sure can cause evolution.
Yeah.
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 Cosmic rays.
Yeah. Pretty darn important.
Yeah.
Hey, do we have time? I would like to tell a little bit about the Frank Oppenheimer story. Do we have time for that?
Go ahead. Dive in.
Yeah, so I mean, obviously, you all know that we are called the Oppenheimer Ranch Project originally, and there is a reason for that. So as I mentioned, Frank Oppenheimer, we are wearing our logos. Look at that, both of us.
Oh, no.
Frank Oppenheimer, the brother of Robert Oppenheimer, also worked on the bomb in World War II. And so one of the things that happened to Frank Oppenheimer is that previously he had, for a temporary period of time, he had joined the Communist Party. And so and left again, but when McCarthyism came around, he was very seriously investigated and harassed. He had to appear before the Committee on, I forget what it's called, the Un-American Activity, something or other. And, this is it's kind of interesting, right? Because we're sort of facing a different kind of McCarthyism today, right? Where we're persecuting people with conservative beliefs. So it's just a different ideology that we're screwing with now. And while I certainly don't agree with communism, spending on being interested in an ideology is no reason to vilify someone. But that's exactly what happened to Frank Oppenheimer. So he gets investigated. He ends up losing his job at the University of Minnesota. He's blackballed from academia. And Robert Oppenheimer had some land in out near Los Alamos, New Mexico. And Frank and his wife came out this way, ended up finding a property in Pagosa Springs, which they loved, in the Blanco Basin, bought this 830-acre property, and apparently also at some point bought another piece of property, which is very interesting. I ended up buying for us, and it is the original Oppenheimer Ranch. So literally it's you've got Frank Oppenheimer's children, and then there's one other owner, and then I'm the next owner, which is really cool. And then later...
So just to be clear, we're not related to the Oppenheimers.
No, we are not related to the Oppenheimers at all. That is not why we call ourselves Oppenheimer Ranch. I know there are some people out there that have some conspiracy theories out there, but not in the least are we related. But, the
relationship is that we both went from scientists to ranchers.
Yeah. And so... listen to this. There's this amazing quote in this book, right? So we read this book. We didn't even realize until later that Frank was instrumental in understanding what cosmic rays are, that we find that out. And then there's this beautiful quote in this book. I think that if you've been beat up by your nation for your political beliefs, and you've built an atomic bomb and seen it used on 200,000 civilians, which Frank had a lot of regrets about, and after a career of cosmic ray research, you find yourself shoveling horse shit up in the mountains of Colorado. It sounds corny, but it really is a pretty good way to figure out what's important in life, to sort out the real values from the artificial values. And for us, that was huge, because that's basically the reason why we are here in Pagosa Springs doing what we do. And by the way, Frank also ended up teaching science at the local high school here. He literally like changed the landscape of what people were interested in Pagosa Springs. Like Pagosa ended up like winning all of these science fairs and stuff. There are old ladies who live here in Pagosa Springs who have come up to us and said, "What do you know about Frank Oppenheimer?" Because they loved him. They thought he was amazing. Like he was considered like a total weirdo when he got here because he's, originally from New York and he's wearing a tie. And then he buys this ranch and suddenly he's ranching, but he's still wearing his tie. And, it's such a cool connection for us. So we had to throw that in there.
Maybe I need a tie.
Maybe you do. Maybe you should wear a tie all the time while we're ranching, Yeah,
why not? So let's get back to the screen sharing cosmic rays.
Yeah.
There are large-scale experiments around the world that scientists are determined to find out more about cosmic rays. So, some of these cosmic rays carry so much energy that physicists are baffled by what object in the universe could create them. Many are much too powerful to have originated from our sun, which is obvious because the solar cosmic rays are much different than the galactic cosmic rays. And because cosmic rays don't often travel in a straight line, and this is due to the fact that there's the cascading effect.
Also because they're bouncing around between magnetic fields.
Well, we have the collectors on the surface, so when we're collecting them down here, we don't even know where they came in.
No, we don't. We have no idea of their directionality at all.
So it's a complete mystery.
Yeah.
But when Svensmark posited that these cosmic rays are nucleating clouds due to their cascading effect, everyone attacked him. And in fact, CERN even developed their own cosmic ray experiment, which is very famous, called the cloud experiment, to disprove him. And they proved him correct.
Mm-hmm. Mm-hmm.
So what they proved was that in a certain part of the atmosphere, due to the cascading effect of these cosmic rays, if the right particles are up there, you can nucleate a cloud, which means that you create a larger particle because you need a larger particle to nucleate a cloud. So can you walk us through in layman's terms what the cascading is?
Yeah, absolutely. So you have kind of like primary cosmic rays and then secondary cosmic rays. So the cosmic rays come into the atmosphere, they collide with the atoms that are in our atmosphere. So for example, if you collide with carbon and oxygen, what you typically will get in a process that's called cosmic spallation, you'll get lithium, beryllium, and boron. If it collides with iron and nickel, you'll get scandium, titanium, vanadium, and manganese. But in this process, you get these secondary nucleosynthesized products. So you'll get, out of that, you'll get X-rays, you'll get protons, you'll get alpha particles, pions, you'll get muons, you'll get electrons to some degree, et cetera, neutrinos, neutrons. So you've got all of these secondary particles as well. But and then you got things like we've talked about muons, or you have anyway, on the channels a bunch of times. Muons come out of pions decaying, and muons, they will reach Earth. They can also go through Earth to some degree, and we've talked about muons potentially being responsible for volcanoes to a degree. So
it's specifically, the muons are specifically connected to explosive volcanoes, highly viscous volcanoes, continental volcanoes like Mount St. Helens, as opposed to basaltic ones that are very calm. So the muons, for some reason in the paper that I've read, heat the magma in the subsurface, whereas other particles don't do any heating.
Well, so I'm guessing because there's a I don't know a whole lot about this, but there's a charged pion, and those are the ones that tend to decay into muons. And then there's like a neutral muon, which, if I remember correctly, decays into like gamma rays. So perhaps the muon is carrying the charge, and that's what's causing the heating.
Yes,
it could be
interesting.
But then, this is also in part how we get like weird radioisotopes that we identify as coming from a cosmic origin rather than, let's say, like from the sun or somewhere else. So like one example is, Diamond, do you have that paper? There's like a Physics World little article that's about, what it's about is a radioisotope of iron, iron 60, that has been found on the moon and also on Earth.
This one, the supernova sediment still raining down
Yeah,
on
that
Earth?
one. Yeah.
Yeah.
So this is kind of interesting because at some point somebody discovered that there was more iron 60 on the moon than I guess what would be present in the background. Now, you could argue that cosmic rays hitting the moon directly could cause the iron 60 to appear, but if that were the case, you would also see a certain radioisotope of manganese appearing, and that doesn't happen. So basically what this is saying is that the radioisotope is being created elsewhere and it's being deposited in our solar system. So that's kind of interesting. And so the idea, and then if you use the half-life of iron 60, you can calculate when the iron 60 was deposited. And the conclusion is that it's the result of a supernova somewhere between 1.5 and 2.3 million years ago. So not a really good estimate, but that's the basic idea.
And
So
at the distance they could calculate too. It was at a distance of 290 to 325 light years away.
Yeah, that as well.
Yeah.
Which I'm a little confused about how they calculate that, right? Because if we're talking about cosmic rays bouncing around in magnetic fields until they gain enough energy to escape those fields, how do we determine how long that takes? I don't know the answer to that.
Yeah, it's all gobbledygook anyway.
Probably. I mean, yeah. So
the same markers we've talked about in other shows that are indicative of maybe cometary encounters. These are the same isotopes, beryllium.
Yeah. I've got a whole list of isotopes that can be created this way.
Platinum.
Yeah. I mean, there's an enormous list. And those are basically signatures of something coming from somewhere else because we typically don't find them on Earth. So pretty interesting stuff. And the other question I have about this is, you and I were sort of talking about this last week. I mean, cosmic rays they're a bit of a misnomer, right? Because they're not rays of energy. They are and they aren't, right? Particles are both energy and particles. There's that conundrum in physics at the subatomic level. But they do have intrinsic mass, right? Because it's literally a nucleus. It has mass. So my question is how much of the cosmic dust coming to Earth is actually in the form of cosmic rays? Like, what is that mass that is coming to Earth outside of other dust? I don't know the answer, and I looked into this, and it doesn't seem like anybody's even investigating this. But it's an interesting question.
If you take a huge amount of nothing, which is basically the nucleus of an atom, it doesn't take up space. It's that's the hard part of math. You need those electron shells to give you dimensionality, right? And the thought that all the stuff that we look at over here is that everything that's solid is really not there. 99.9% of this travel trailer is space.
Yeah. Well, I mean, 99% of everything is space. I mean, 99% of your body is space even, right? Yeah. But it adds up, right? Like, the nucleus of a lead atom has, I don't remember what the number is, but it has a significant number of protons and neutrons. Like, it has mass, but that's also true of a hydrogen nucleus. Even though it's really tiny, it still has mass, and it adds up over time.
That's interesting. And we're at a time, we're in a magnetic excursion where the cosmic rays are increasing. And in the last 2 solar cycles, we reached the cosmic ray maximum.
Mm-hmm.
Yeah. And it's only going to get higher.
So it's the maximum out of what we've recorded before? What do you mean by maximum?
The highest recorded since we've been recording cosmic rays.
Okay. Yeah.
It's called the modern maximum. It was at its lowest during solar max, because when you hit solar max, the magnetic field of Earth gets amazingly strong because the sun is continuously hurling flares at us. Yeah. And back in solar max, the magnetosphere was so strong, the cosmic rays were low. They were barely getting in. But we've reduced our field strength by a lot since then, and it's continuing to diminish. And so the cosmic rays are spiking. Every solar minimum, we reach a new cosmic ray maximum.
Yeah, and you have a couple of different factors determining how much of cosmic rays are coming in, right? You've got the actual cosmic ray flux, right, which surely could vary. Like, let's say we're in the spiral arm of the Milky Way galaxy, we'll be getting more. And then, of course, the strength of the Earth's magnetic field, as you were just discussing. And then it also depends on the energy of the cosmic rays themselves.
Yeah, we have
and the solar wind.
So here's the cosmic ray readings here. And if you go to spaceweather.com on the left side here, they will give you Oulu neutron counts. So Oulu is a monitor, and maybe it's in Hawaii. It sounds like it.
Oh.
But these monitors are all over the place. So when you're looking at the KP indices, when the KP increases, the cosmic rays are increasing. I mean, that's basically what it's showing you. And it's different based on your geography. Look at these
absolutely.
3 different stations. At this station, they're at KP6, but at this one, they're at 4.
Yeah. And then, of course, it'll vary with altitude too, right? Like us living up in the mountains, we're getting more cosmic rays on a regular basis than people are who live at sea level.
Yeah. And the worst place you can be is in, guess where?
An airplane.
Well, but if you're on the surface, where is my picture? There. If you're on the main auroral belt.
Oh, yeah. Yeah.
I mean, this is literally where the cosmic radiation is funneling into the Earth.
Yeah. And that's also where you tend to get heavier and heavier nuclei that can come through. Now, granted, the nuclei tend to not really fall to the surface. What falls to the surface typically are the small particles, the pions and the protons and the alpha particles and all of that stuff. But still.
Because the cosmic ray is breaking apart into those constituents as it cascades down.
Right, because it interacts with molecules that are in the atmosphere, and then you get that secondary cosmic rays, which were all those really tiny particles.
Do any of them miss everything and make it through?
Well, I know that the muons make it through.
Yeah, but the initial high energy particle, I'm saying, it probably always cascades because we have so many atoms in our atmosphere. Right.
I am guessing, I actually am not totally clear on that, but I'm guessing in some way, shape, or form they do eventually. I mean, they're in the atmosphere, right? If we're making lithium and beryllium in the atmosphere, at some point it's going to reach the surface.
Yeah, and we don't know how far it can travel. You know, from its initiation. Let's say it comes in at the North Pole. It might end up in Australia.
Right.
Nobody knows. Right.
Well, and then certainly like at the North Pole, I would guess just, you know, that's something like a heavier nucleus. Well, I said this already, is just going to have a easier time getting through to the surface because there's less magnetic field to block it.
Yeah, this is an interesting map because it's probably the most important maps you can look at when looking for a safe place to live during a magnetic excursion. Yeah. If it goes full reversal and you're up above the green line there, or anywhere in that region, that could be a very detrimental place for plants and animals to live because it's literally where the most cosmic radiation is going to be pouring into Earth at the lowest field strength.
I wonder about that though, right? Because it seems like when we're in a magnetic excursion, part of the process is that the field gets less polarized, right? And so you've got more areas that are kind of like wishy-washy about what charge they're taking. So I wonder, like in the process, like especially at the zenith of an excursion, you might have weak areas of the magnetic field in a lot of other places as well.
You absolutely do. They've done reconstructions, and we've discussed this, that like during the Lechamp at the minimum field, when the VADM went down to 2 or less, the poles showed up at the equator, multiple poles. They were like flipping around. So the auroral belt will be destroyed, right?
Yeah.
It will be placed in other areas.
Well, and then you could argue too that there's potentially evidence of that in what we were talking about last week. Was it last week? When we're talking about major extinctions and you see great difference. So at a given period of time, let's say at the Lechamp, you're seeing massive amounts of I can't remember exactly now which places saw more extinction than others, but like North America's extinction levels are much different than what you find in Africa. You know, and some of that is probably
Dryas.
Younger Dryas. Okay, yeah. So I don't remember exactly what happened at the Lechamp in terms of which continent suffered more extinction, but certainly latitude plays a role, but there's also like a localized effect, it seems, of some kind.
Yeah, that's amazing.
Yeah.
And so then we can really sum it up here we only have 8 minutes like or so left, maybe less because they cut us off early last time.
Yeah.
Is this paper that just came out a few days ago. On the 6th of March, the influence of solar modulated regional circulations and galactic cosmic rays on global cloud distribution. Did you get to look at this?
I did. Yeah.
And basically what it concludes is everything that we already knew, that the solar cycle modulates galactic cosmic rays, but only a little bit. But when they were looking at a regional pattern, it really didn't have a marked effect on cloud production, which is what everyone assumes.
Except that what they do acknowledge is that there's, it's probably like individualized effects on the various climate patterns on Earth.
Yes.
Right. Like the mid-Atlantic decadal oscillation and stuff like that. So you've got cosmic rays interacting with those patterns, and that may account for the differences in how many clouds are nucleated.
And so here we can see on the graph what Leah just said, that the dotted line here is the galactic cosmic ray fluctuation. The other lines are cloud anomalies, and that the general consensus is that there may be a lag time or something, but it's a larger forcing mechanism than immediate.
Yeah. Well, and it's more complicated too. There's a lot of other variables involved as usual.
Yeah, which is the weather is impossible to predict out more than 72 hours. No one knows how to do it.
Yeah. By the way, I want to throw something else out there too that I just discovered yesterday as I was reading. It turns out that there's two scientists, one guy named Edward Ney in 1959 and another guy named Robert Dickinson in 1975. And they actually proposed that cosmic rays are responsible for major climatic change and mass extinction. So kind of like predating Robert Felix. Now, granted, they were looking at this kind of in a different way. They were looking at a 62 million year cycle and how that had an impact, that cycle correlated with marine life. And they're looking at this in correlation to our position to the galactic plane, et cetera, et cetera. But nonetheless, like they're seeing a connection there between climate and mass extinction and cosmic rays. So a little ahead of their time.
That 62 million year cycle is thought of as us traveling through the arms of our galaxy at that periodicity.
Oh, okay. So they're really like foreshadowing Sven's mark.
Exactly. No, actually, Lieb Shaviv, whoever the guy is in Israel, he's the one that worked that out.
Okay, but that's what they're talking about here. I mean, not exactly in that fashion. They're just seeing the correlation at the 62 million year cycle. And they do propose that the galactic plane has something to do with it.
Yeah, and so that would be the spiral arms. When you look at the Milky Way, it's got those white arms. Every 62 million, we're going through one of those, and that's the forcing mechanism.
Yeah.
Now, what's interesting is that the current thinking on mass extinction isn't about galactic cosmic rays, but they are certainly increasing during these magnetic excursions. What they point out is the UVB.
Yeah, yeah.
And so it's actually going to be, it's not one or the other. It's like everything we talk about. It is a cocktail of catastrophes all happening at once.
Yeah.
So if you have increased cosmic rays, you're going to have increased mutations, and that's going to give you the mechanism you need for speciation. Mm-hmm. And at the same time, the UVB is killing the biome. So by killing off the biome, you're adding new ecological niches for these new species.
Yeah. And then you also have the cosmic rays also potentially causing mutations as well, right? Because of what I said earlier, you've got, a large cosmic ray nuclei will break a DNA strand, but it's all radiation. It is all radiation energy. So it's going to have some effect on our DNA.
Yes, it is. And expanding Earth is going to have an effect on how many people can live on Earth.
Yeah.
So that's going to be a really interesting topic to get to next week.
Yeah.
But let me stop the share so people can see us again. because we're so tiny down there.
We are tiny. We are tiny.
Have we stopped sharing? Okay, good.
No, yeah, we have.
All right, we got a few minutes left. So I think you didn't hear what I said because you just repeated it, that the mechanism during these magnetic excursions going on, as the field strength goes down, the cosmic rays come in and increase. Yes. So at the peak of the field reduction is when the speciation happens due to cosmic rays.
Yes.
It's the UVB that's causing the extinction. And by causing animals to go extinct, we have these new areas where they can now flourish, the new species.
Yeah. Yeah, definitely.
That's been a great show. Thank you all for joining us. Support Revolution Radio, the #1 listener supported radio on the internet. It's awesome. And we can talk about anything we want.
Yay.
And that's boom.
Take care.
See you next week.
Listen to Revolution Radio at freedomslips.com, and we'll be right back after this message.